So, question 9. For a function f defined in a suitable domain, it is known that f dash x is equal to 2x plus 1 over root x, and we know that f of 9 is equal to 40. So express f of x in terms of x. So basically they've given us the derived form, and they're asking us to give us the original form. So the opposite of, to go back from a derived form, we're going to have to do the opposite of differentiation, which is integrate. So it's actually an integration question here. So f dash x equals 2x plus 1 all over root x, and then we want to say something like f of x is equal to the integral of 2x plus 1 all over root x. Okay, so what we're going to have to do is differentiate this term. So we want to prepare for integration, which is going to be like so. So 2x plus 1, and then you're going to, instead of having this to the half, you're going to want to have this over x to the 1 over 2, and then it might even be good to separate the terms. So 2x over x to the 1 over 2, and then over here plus 1 over x to the 1 over 2. Okay, equals, and then you're going to want to bring these x terms up to the top. So because that's going to be a negative, that's going to come up to the top, and that's just going to become a half. So it's going to be 2x to the 1 over 2, because remember that is 2x to the 1, you should see the 1, and then you plus, then this just becomes x to the negative 1 over 2. Okay, so now it's ready to be integrated upon. So let's put the big integral sign in there as well, don't forget. Okay, so now you increase the power by 1, so this becomes 2x, and increase this by 1, so this becomes 3 over 2, and then you have to divide by that same power, so this becomes 3 over 2. Okay, and then you have to do the same on the other side, so x plus 1 becomes a positive half all over 1 over 2. And this is really important, don't forget this plus c, this constant of integration, because it's an indefinite integral, we don't know what the bounds are, so we have to have this constant here. Okay, so let's simplify this expression a bit. So then this just becomes 2 goes to the top, but the 2 side becomes 4x to the 3 over 2 over 3, plus, well, this 2 will go to the top, 2x to the half over 1, so that's just as is, and then plus c. Okay, so that's the first part of the question, but what they're asking us is to express it in terms of x. So we're going to have to get rid of this plus c somehow. Well, how are we going to do that? Well, we're actually told that f of 9 is equal to 40, so basically that's saying when we put 9 for every value of x, we end up with it being equal to 40, and if we know that, we can work back to calculate this c. So f of 9 is equal to 40. So we're going to sub in that to the equation. So 40 is equal to 4 times 9 to the 3 over 2 over 3 plus 2 and 9 to the power of 1 over 2 plus c. Okay, so the next part, so the next part, so this some people might be panicked by this term here, but if you just simplify it down to ways you might have seen it before, so this 2 is the root, this is actually root 9 to the power of 3 all over 3 plus 2, and the square root of 9 is just going to be 3, isn't it? That's the same half, it's just is the same as having a square root, so this just becomes times 3 plus c. And actually, because of this square term here, it's divided by 3, and this is the same as multiplying by 3, so actually this comes down and that becomes squared, which makes life a bit easier for us. So this actually becomes 4 times, and we know the square root of 9 is 3, 3 squared plus 2 times 3, which is just 6, plus c. So this becomes 4 times 9 plus 6 plus c, which then becomes, so 4 times 9 is 36, so 36 plus 6 plus c, this is still all equal to 40, 40. So 36 plus 6 is actually 42, so 40 equals 42 plus c, so c must equal -2. Okay, and I'm just going to squeeze it in here at the bottom. So that means that, so therefore, f of x is equal to 4x to the 3 over 2 all over 3 plus 2 to the power 2x even. You could put it nicer, you could put 2 root x minus 2. That's your final answer there. Sorry, I had to squeeze it in there at the bottom. Okay, there's 4 marks here, so where are the marks? So your first mark is for writing it in a integratable form, which you've done here. Your second mark is for integrating one term, and then your third mark is for completing the integration, so here, and then your fourth mark is for stating the expression for x. So right down here, there's quite a lot of work for the last mark, so you get most of your marks just for getting to here, and this is only actually 1 mark. Okay.